All right, everyone. Welcome to our I guess the sixth distinguished speaker in our series this year. I'll have Jim, her host, introduce the speaker.
Sure. Yeah. I'm really happy today to be able to introduce Professor Peggy Storey, who comes to us from University of Victoria. Since she comes from Canada, we just tried to arrange some weather that would make her feel at home. The sleet might have been going a little too far, but it's okay. So Peggy has, among other things, among her many contributions, she has an uncanny ability to spot trends. They're just starting in the commercial world, little things on the horizon that nobody else is paying attention to. Peggy can see this is going to be a big thing. So, for example, a few years ago, she started studying use of social media by developers. And she did some of the very earliest research. She basically helped shape the research agenda for the whole community, gathered a community of researchers around her, and made a huge difference to sort of find that whole area. A little bit later, it was bots. Right? And she was the first to see that really chatbots that she started looking at, 3 or 4 years ago. And they're a big deal now, but she saw it way back then. So in addition to that, she's done a lot of work on developer productivity and the whole developer experience, and really trying to make that experience better, more productive, more comfortable for developers. And she's done all of this very often in collaboration with industry. She's worked with Microsoft, she's worked with IBM and many other companies. And so her work has had an impact in industry that's almost unequaled among software engineering researchers I know. So she's here today to talk about automation, automating software to empowering developers. So please welcome Professor Storey.
So thank you very much for the kind introduction. I will say that I think my ability to spot trends comes a little bit in part from working with great students and great collaborators, but also reading stuff, reading stuff that people are writing about in blog posts online from the industry, and sort of paying attention to some of that. And in research, we have a gap, right, between what's happening in industry and what's happening in research. And one of the things that I'm hoping to do in the next few years is close that gap a little bit, because I think we have to, especially with what's going on today. So today I'm going to talk about automation or automated software engineering, and looking at it through the eyes of the developer. So often this field of automated software engineering is very much focused on how can we improve kind of the velocity of the way that we're writing code, or improve the quality of the code, or the reliability of the code. And what I want to talk about today is really looking at these questions through the eyes of the developer, how we can use automated techniques to really empower developers to do their work joyfully. So what I'm going to do first, though, is I want to look back a little bit at the history of automation in software engineering, and then look at future innovations and research that we have in this area. And then at the end, talk about how to evaluate the impact of automation on developers. So before I talk about automation and software engineering, though, let me go back a little bit before software engineering and talk about automation in general in the world. So, well, since the beginning of civilization, people have, tried to create crafts and tried to do their work, tried to create automation, or tried to create machines to help them do their work more efficiently. And in the very early days, it was harnessing, animals to do some of the work for us, or using the wheel, or using pulleys and lever to help do our work more effectively. And then over time, of course, we had more innovations, and we had more complex systems with control loops and so on to help us, do that, use innovations and inventions to do our work more effectively. So back in the 1800s, there was, a lot of talk about how machines were going to improve the lives of people. So you might hear a little bit, I have a bit of an Irish accent, I'm Irish, so I always like Oscar Wilde quotes. So back in the 1800s, Oscar Wilde had this quote about, while humanity will be amusing itself or enjoying cultivated leisure or making beautiful things or reading beautiful things or simply contemplating the world with admiration and delight, machinery will be doing all of the necessary and unpleasant work for us. So he had this quote going back all the way back in the 1800s. So machines were followed not long after by the term automation. Actually, the word automation, I think, came about in about 1930. And in fact, the word wasn't really coined in popular sort of notion until about 1946. And it was coined by Henry Ford, right, in Detroit for manufacturing cars. And the goal here was, to reduce human intervention in these processes. And in fact, Henry Ford also created an automation department to help ease the way that cars were being made. And a key aspect of automation was this notion of control loops. So the ability within to get these feedback loops within the system that integrated controllers and systems and sensors that would be measuring, if you like, the output of the system, giving feedback back into the system, measuring errors maybe from that process, and then again going back into a controller and back out into the system. And this was a really, really important aspect of automation, this notion of feedback in the system and getting feedback back to the creators and also back to the machine itself. So we have lots of advantages of automation in general here. So we have, the faster production of goods. We have higher quality. That's what the purpose of this feedback was for. We have, of course, cheaper and safer. We have more predictable processes and products. We have less tedious, repetitive work. So human beings aren't necessarily very, patient at doing repetitive, tedious works over and over again. It automated simpler tasks, and in fact, often for the human, made the task simpler to do as well. And it left more time for creative work, which is what people are really, really good at. But the ironies of automation, or the disadvantages, these are often called the ironies because they're almost the opposite of what automation is designed to create, is that the automation that we add to the system, on the one hand, it may simplify the tasks that need to be done, but on the other hand, it requires different competencies and skills to use that automation. And retrofitting automation is complex, and any errors that may occur may be multiplied. So we see this in very early days of systems such as the Therac radiation machine. And you may not anticipate all contingencies of how the system is going to be used. And these semi-automated tasks rely on people. And in fact, we know from research that people are poor monitors. Okay, we're not good at watching things. In fact, another irony of automation is called the bystander effect. I'm sure many of you have heard about this, right? That if you have a lot of people kind of observing something, nobody does anything. You might have seen this if there's, a little fire somewhere and 10 people are standing around and nobody calls 911. Everybody just kind of stands around watching. And so this can happen a lot with automation when there are a lot of people so-called watching it that they don't notice what's going on. And this leads us to the paradox of automation, is that the more efficient the automated system becomes, the more crucial the human contribution becomes of the operators. So Jim and I were talking about Teslas today, right? That, Teslas were moving, that your need to be monitoring as much as what's going on, but actually human monitoring is even more important in those situations, not less. So long time ago, so there's a lot of younger people in the room. And so you won't remember what it was like in the old days when we learned how to program and when we didn't have object-oriented programming at first, and we didn't have sophisticated IDEs. And what we would do is we would get up in the morning and we would decide what code we were going to write. And we would create this mental stack of the things that we had to author. And then we would spend the rest of the day implementing all of the things on our stack. And this mental stack was, if you like, a huge to-do list. In fact, a lot of programmers would have a piece of paper writing down things, right, that they were doing, right, in the early days. And if you wanted to change a variable type or you wanted to rename a variable, you had to painstakingly go through your code and make that change, searching or grepping for those instances and make those changes. Of course, today with object-oriented programming, we can use abstractions. And with the IDE and refactoring tools today, those can automate those things for us, and they remove some of that work. And these were godsends, right, for old timers. And along the way, there were lots of other stumbling blocks, using punch cards, for example. So today we have, all of these tools that we didn't have, and there's been this long history. So when I was preparing this talk, I tried to find if there were any systematic literature reviews or summaries of what does automation and software engineering look like. And I did find a paper on arXiv. I don't think it's been published since then. And it looks at this taxonomy of automation through two different ways, the what and the how. And so in terms of the what, this paper looks at how automation is done in software engineering through different phases of the life cycle. So there's automations that are brought in at the requirements engineering phase, high-level design, low-level design, testing, verification, and maintenance. And then in terms of the how, it looks at all of the different techniques that are being used, such as mathematical modeling, different programming paradigms, even human-computer interaction and artificial intelligence as well. So there's been quite a lot of work in the software engineering community on using automation in software engineering. And these authors look at the research trends up until 2016. And what you'll notice is that around 2016, there was a lot of research in automation for testing and verification, whereas earlier it was more in the implementation. And then that kind of tailed off, and a little bit for maintenance as well. And also, what's that one? Requirements engineering. Now, if we were to extend this graph, what do you think it would look like? What do you think would be the tallest bar right now in terms of automation? Implementation. At least it would be catching up in terms of papers. Okay, you would be seeing that trend, right? And they also looked at the different techniques that were being used, and you'll see up till 2016, artificial intelligence is kind of short, right? And this one is, if I remember correctly, mathematical modeling. We would probably also see a bit of a flip there as well. More use of artificial intelligence, deep learning, and so on. So looking at software engineering in terms of the topics that are submitted, this is the Automated Software Engineering Conference. And so I looked at these papers and I created a visualization. You can look at that if you like at that link. And you can see that AI and software engineering is increasing as a topic. Okay. And in fact, I would guess if you look at this for 2023, you would see an even bigger skew of that. And we don't just see it at ASC, we see it at ICSE for 2023. If we look again at the topics, you'll see that AI and software engineering, or AI for software engineering, or software engineering for AI is really increasing in terms of the number of papers. So this is a huge trend, not only in our research community, but also in industry as well. But what are the disruptive? If we look back in time over software engineering and think about what are the disruptive automations in software engineering industry. So I made an attempt at this, and there are a lot of smarter people in this room than me. They may add some things or disagree with some of the things that I have here in terms of the disruptiveness. But let me just share with you a view that I have on what kinds of disruptive automations we've seen. Well, way back in 1968 and 1970, actually there were earlier disruptions, but let me start when the term software engineering was invented in 1968. We had the introduction of high-level programming languages and object-oriented concepts and small talk. Okay, and these really changed the productivity of developers, right? That they didn't have to go through and manually, update code. They could reuse the abstractions, reuse code. Then around 1990, Johnson had this idea of refactoring, that we could automate refactoring. It didn't have to be done manually, right, by searching through the code. That was kind of the first mention of that term. And then there was something called ICQ. Anybody know what ICQ is in the room? So a couple of people showing age here. So, ICQ was this environment where you could chat with other developers. And it also had bots in it, by the way, chat bots all the way back then. And it was a way that you could write scripts and you could automate things and you could also communicate with other people. So it was this very interesting ecosystem that supported communication across developers, but also communication with bots. Of course, they were quite naive, right? But these bots that would do things. Then we had IDEs. There's this expression, and I don't know who wrote it, that when it's time to build trains, everybody builds trains. So there was, at the same time, there were all of these new IDEs that were coming out. The time was right. There were ideas for automation, and building these automations into the IDE made perfect sense, right? So we had, of course, Java came along, but we had IntelliJ and Eclipse, and then we saw frameworks, right, like the Spring framework that again increased the productivity of developers. And then this is Stack Overflow. So I remember when Stack Overflow made its way onto the scene, and of course, Google search as well. And can any of you imagine programming without Stack Overflow today? Right? We can't do it, right? The internet goes down and you're done. It's like, okay. You can't watch a movie either, though, because you also depend on streaming for things. But anyway, you can read a book. So I don't know if you would call Stack Overflow necessarily automation or not, but I think it is an automation behind the scenes, right? And how it gathers and curates the statistics and how people use it and the algorithms for finding stuff. And then more recently, and I had to just squeeze this in here, the OpenAI symbol. Refactoring my design here wasn't very easy, but now we have Auto ML and GitHub Copilot. And just in the last few weeks, ChatGPT, right, is just turning everything on its head, right, for many of us in the community. Many of us are realizing that ChatGPT is probably, or, the use of AI is as big as the internet was, right, in terms of disruption, right, on development. And by the way, the internet came in around here, right? And then, so that was looking at code authoring. I'll speed it up a bit here. Let's think about testing, verification, and analysis. So the idea of test automation, so this idea that you could, write tests and you could automatically run them every time you made a change to the code, came about fairly early, actually, in 1980 by IBM. And there's some mention that other people had the idea at the same time, which is probably true. And then we had unit testing, this idea of unit tests, and then Selenium, right, for doing web testing, could watch how we use, a web interface and then generate the tests from that. And then tools for doing static analysis and ensuring code quality, such as SonarQube. So we didn't have to do that analysis ourselves. We could rely on the automation. And then more recently, we have the use of AI in these testing. I just put a couple of examples here, Sapiens and Dependable. Then looking at versioning and review, can you imagine not having versioning when you write your code? Any of you work with colleagues from across campus that don't use versioning and you have to write documents with them? It's like crazy, right? But, versioning wasn't always a thing. And it was the mid 70s, right, where the ideas for versioning control, version control systems came in, RCS and CVS. And then it was some time before we had more sophisticated interfaces such as SourceForge. And then, of course, GitHub, which brought the social aspects into version control, arrived, I guess around 15 years ago now. And then we have a lot of automation for another challenge, which is building and continuously integrating our changes. And also creating, Dockers and images of our systems and tools like GitHub Actions, right, which create these continuous integration pipelines, right, which automate a lot of the tedious work, right, that we had to do in software engineering. So we have some pretty amazing stuff, right, going on in software engineering, and a lot of it fairly recently. But all of these automations were inspired by practices or by understanding how people work together. So for example, the agile, even code inspection, Fagan's code inspection, motivated the idea behind a more automated approach to code review, which started in open source and then was eventually, added into code review tools that we use in the rest of the industry. And then there was the whole agile thing where people, were placed above processes, and this focus, on people then pushed its way into the tools, the automated tools that were developed. And then, of course, the DevOps movement, this idea that, operations and coding could be integrated and removing some of the friction from that. And then finally, where we are today is trying to think about machines that can think like people or act like people or, author code like people, is pushing down into the technologies that we have created. So this is just my quick view of, some of the disruptive automations. And we're over here and we're at a dizzy part really of disruptive automation going forward. So what are some of the advantages? I don't think I need to convince most of you in the room that there are many, right? So, increased productivity. Many of these tools support high-performing teams. They make developing software more predictable. They make it more flexible for us. By having automated tests, we can, make changes very easily. We can adapt, we can test it quickly. We have this notion of fail fast that maybe you don't see so much in other engineering disciplines, right? We can deploy changes to our end user base and get feedback really quickly, right? From some of our poor users, right? Who find Netflix won't work for them tonight, right? These automations really support a lot of the stuff that we do. This experimentation, this learning, these tools support all of that. And there's lots of research that show that developers are happier, right? That they're more joyful, they're not doing the tedious work. But there are also some disadvantages as well that we tend to forget. And especially as researchers that I think we need to pay attention to, not just the advantages. So, what happens with any technology or any automation? So Marshall McLuhan talks about this. What happens if we misuse it, or if some of the people that we work with abuse the automation or just even overuse it? Instead of, relying on people, they just turn to the technology to do it, such as in Tesla cars. But there's other issues such as hidden dependencies. So I think I was explaining to Jim today, or somebody I was chatting to, that when I first learned how to write code, I would read the user manuals for the different frameworks that I was using. I was kind of geeky, I have to admit, but I would read the user manual from cover to cover. And then I understood pretty much all of the code that was in my system. Even though I was working with other people, I either understood it or I knew exactly who understood it. And I had this feeling of control. Today's development is so complex. There are so many layers of abstraction, so many hidden dependencies, that it's impossible to feel like you even know the lines of code or understand what the lines of code you wrote yourself are doing, because we're relying so much on this ecosystem of knowledge that's out there. And does some of this automation lead to breakdown of collaborations? So there isn't as much, in the old days when you worked in open source, there was a lot of communication through the mailing lists. And there's communication now through other channels, but maybe not as much. And maybe as we move more and more towards more and more automation, those collaborations break down even more. So lots of potential disadvantages. I wanted to just look at one example of, the advantages and the disadvantages of automation, and that is looking at continuous integration. So continuous integration in the big scheme of that map of software engineering is fairly new in terms of the technologies. And there's certainly lots of advantages, right, from using it, right? So, productivity, speed, getting your changes out to your users faster, having traceability if it breaks, being able to see which commit potentially led to that break, and also happier developers because they're seeing the impact of their work sooner, because continuous integration allows them to push their changes, get them tested, get them code reviewed, get them built and deployed to their customers, right? But there are also some disadvantages from using continuous integration. So there's more cognitive load. And actually Pinto et al. Studied this and noticed that, build code is code too. And now you have to maintain the build code. And there is a barrier to entry to a lot of developers who want to contribute to open source projects because of this added complexity. They have to understand how the entire build system and the build scripts work to be able to contribute. And this leads to difficulties attracting developers because of those barriers. So instead of making things easier, Mary Shaw and I were talking about vernacular developers, which I love that term. So not the experts that are software engineers, but this extra infrastructure adds another barrier to other people joining these projects. And another thing is that failing builds lower developer morale. We've seen that as well. So there's this notion of fail fast, but actually as you're building your code and you're seeing fail, 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 that can, lower your level of happiness as well. And I brought up this kind of, almost heretical kind of notion that maybe going fast and keep going faster and faster shouldn't be our goal. Like maybe going too fast is bad. And there's this example of pipelines in the US, which go across states. And they saw one of the side effects of using those pipelines was that wolves were able to travel along these pipelines and go outside of their ecosystems into other ecosystems. So this notion of there are these side effects that you might not think about. And so I asked a bunch of developers, and I was in a workshop with them about, how did they feel about continuous deployment? How had it changed their lives since before continuous deployment? And one of the things that I hadn't seen mentioned in any of the literature, or even in the workshop, but that they brought up in discussion was that they were getting burnt out from continuously deploying their code. So in the old days, like old days, a few years before, they would deploy new versions of their software maybe once a year or once every 3 months. And guess what they did when they deployed a new version? They had a party, right? They had a party and they took time off, right? And they went, yes, we achieved that goal. And then they would kind of have a lull in their activity. Whereas with continuous deployment, where they're deploying changes all the time, they never get that chance of feeling we succeeded, and they never get that chance of kind of slowing down. So there can be side effects that we don't always think about. So I've looked a little bit at the history of automation in software engineering. And now let's look a little bit to future innovations and some research. And I'm just going to pick on a couple of directions here. So I wanted to ask you a question. So I know that CMU is one of the top, departments of computer science, and I know you're S3D, but you're all within the School of Computer Science, right? So you're top in the world, right? Would you agree?
Yes.
Yeah. Good answer. So what do you think? Can we fully automate software engineering? What do you folks think? No. Anybody think we can? Yes, one person, brave person. Yeah, okay. I'll ask you later. I don't agree, but that's okay. We'll talk about that later. So what do I mean, though, by software engineering? What do I mean by software? So, well, what is software? What is it? Right? Is it, the lines of code that we write, or, eventually the binary code that it produces? Or is software what it does, right? What it does for us, right? Connects us to Netflix. I don't know why I keep thinking of Netflix. I'm sorry. I didn't get a lot of sleep last night. Or is it what people do with it? So maybe software is how people use the tools in ways that we don't imagine. So think of Twitter, right? Think of how over the years people have taken Twitter and adopted it to uses that they didn't think of initially, right? Like the hashtag, right? Came from how users used it, or retweeting. Or is it what it can be altered to do? So is software about the possibilities of how people can imagine new ways that the software can be used and their ability to then change it? So I don't know what you folks think, but I kind of think it's all of these things, right? So looking at how other people define software, I'm going to turn to Peter Nauer, who has this really beautiful paper from 1985. And he actually talks about software as being shared theories about problem and solution domains that are in the minds of developers. So this is what he defines as software. So the code, he says, it really isn't so important. When a company buys another company, they don't just buy the code, they buy the developers, right? They buy the experts that understand the software, that understand the possibilities. Or Jessica Kerr, really great talk, by the way, that she gives. It's in a few different places. She talks about how today software is really complex, and any system, nobody understands, how that system works. It relies on the mental models of many, many people. And by the way, everybody's mental model is incomplete and out of date. And that doesn't matter, but we do need them all, right? And then together, the people that understand all of the different parts can work together to maybe make the changes to the software. And then finally, Jean Yang, she says, well, people are part of the code. It isn't just the code, it is the people that wrote it. So with that in mind, here's a definition that I'm going to put forward. Software is a dynamic, living, learning system comprised of people and code and tools and environment, and the exponential relationships between all of these parts. Actually, Jessica Kerr talks about those exponential relationships between these different things. So anytime you make a change to your environment or to your tool or to the people or to the code, it has, many, many outcomes that have to be taken into consideration. So this is why our job's so hard and why, we're always going to have interesting things to do, because it's a very, very complex system. So if we think about software development, so if we think about this definition, okay, and we think about what innovations lie ahead in software development, how can we approach this? How can we think about what innovations we can explore? So for this, I'm looking at a book called The Innovation Biome. And in this book, Mehta talks about 3 different types of innovations. There are other models of innovation. I'm just going to use this one in this talk. But he talks about the first kind are incremental innovations. So you could imagine, another version of the Netflix software, right? Or another version of a testing tool or a refactoring tool. There was already an idea for that, and then there is an incremental way to improve it. Maybe make it faster, maybe make it, more accurate, and so on. Then there are what are called breakthrough innovations. So what do you think are some examples of breakthrough innovations? I gave you some hints earlier. Well, the internet, right? Yeah, the phone, right? Mobile, Google search, Stack Overflow, potentially. What else? AI, right? So these are all examples, right, of breakthrough innovations. And then there are experiential innovations. So experiential innovations are things like, I need a tool that does this for me. I need a different way to keep track of my notes, right, that are tied to the different parts of research that I do in my life, right? I need this, right? And as developers, what's super cool is that we can scratch our own itch, right? We can create our tools, right, to address our needs. I love this example of how the Make tool came about. Do you folks know what Make is? I'm not even sure that people today know what Make is. I'm just realizing how complicated so fast. So Make originated, was designed by Stuart Feldman, and the idea for Make came from, talking to a problem that Steve Johnson mentioned with him, where Steve had spent a morning debugging a correct program. I don't know if any of you have done this, but I mean, with today's tools, it's not so likely, but I know that I spent a lot of time in my early years programming, fixing bugs I'd already fixed because I hadn't compiled the code, right? And so he was talking about this, and then that's where the idea for this way of automating, you make a change and you automate how the tool is built, came up. And Stuart said that, spent a lot of time thinking as some pretty sophisticated stuff, such as a dependency analyzer. But in the end, he said, it's really not that complicated a problem, right? And he came up with a pretty simple solution. And in fact, he said, Make files were text files. They weren't magically encoded binaries that not everybody could read, because that was the Unix ethos: printable, debuggable, understandable stuff, right? And so I really like that. And I think, being driven by not just your problems, but also by your values in how you design tools can be really powerful. So what kind of experiential, so we've got the breakthrough innovation right now of AI, right? But what experiential innovations might there be out there that we can explore? How do we know what those are, right? How do we, maybe they're even solved, right? How do we recognize that they're out there and we can share those great ideas with other people? Well, there's two sort of important things to improving our experience, right? We want to minimize our pains and we want to maximize our gains. And we want to not just automate, but we want to, hopefully I've convinced you a little bit, maybe not the person in the back, we'll chat later, to augment, right? No, I love that you put your hand up, we'll talk later. But augment, we need to argue in research, by the way, we need different opinions, it's really good. We need to augment, right? Empower what developers do, right? So we can make them more productive and also improve their experience, right? So some of you may be wondering, well, what the heck does more productive mean? And I've actually spent probably way too long studying this, what developer productivity means, because the term productivity, like ask yourself, are you being productive right now sitting here? Right? You know, you could be somewhere else catching up on email or doing an assignment or something, right? It's very hard to answer, right? What being productive is. But yet a lot of focus in industry has been on sort of understanding and measuring developer productivity. That's a whole other rant for another day, but there were companies that used to measure developer productivity by lines of code or even pull requests. And so together with some colleagues, we've been studying the sort of challenge of what developer productivity is. And we came up with this framework that productivity is not just one thing. It's a multi-dimensional problem, if you like, or concept. And so we often think of it in terms of activity, or maybe we think of it in terms of performance, like how many features did we ship, what were the quality of those features, or how fast did we, respond to change to breakages. But productivity is also important to think of in terms of developer happiness, developer satisfaction, and well-being. Okay, because developers are part of our system, so we need them to also be thriving, right, as they're writing code. We know that software isn't written by one developer alone. It takes a whole network. It takes a whole community. It takes many teams, high-performing teams. So collaboration and communication is important. And then the last one that I'm talking about here is in terms of efficiency and flow. So I put in a couple of, I'll get to that in a minute. Another way of thinking about productivity, sorry, I forgot, I just snuck this in because I watched this talk yesterday. Hans Doctor gives a talk on improving developer productivity, and he defines productivity as joy, right? The joy of developers, right? If what we're doing makes developers feel joyful, we're making them feel more productive. And I just really like that, that putting that out there. So I've also we've looked at developer productivity, and we have that SPACE framework. And I also did some research with my colleagues, Michaela Greiler and Abhi Noda, on looking at, well, what is developer experience? So it's a little bit different than developer productivity, which is looking more at the whole process. Developer experience is really focusing on through the eyes of the developer. And we did a lot of research. I'm not going to talk much about this paper, but we identified over 40 factors and different contextual characteristics and barriers to improvements, as well as strategies and coping mechanisms that developers feel. You can see that paper, but what's interesting out of this work, as we've been applying this framework in an industry through a tool that we're using, is that three core dimensions of developer experience keep coming up over and over and over again. And the first one is this notion of cognitive complexity. So if the tools that you're using are complex, or if the code that you're working with is complex, or even your requirements are complex, these are really going to impact developer experience. And the second one that keeps coming up is this, and this goes back to automation, right? Those control flow loops that I talked about and the faster feedback, is what is really important to developer experience is getting fast feedback. So that's why continuous integration is so powerful, because it gives fast feedback to the developers, right, on the changes that they made, that their tests pass, right? But it's not just about getting feedback from the tools, it's also about getting feedback from others. So if you're waiting for somebody to review your code, that will impact your experience. And then the third one that we talk about is developer flow and fulfillment. So what do I mean by developer flow? So there's this theory that is decades old now called flow, which is a state of mind. It's a holistic sensation that people feel when they act with total involvement. Any of you been writing code late at night and looked at the clock and seen that it's 3 a.m. and you didn't notice, right? You were in flow, okay? You had no interruptions. The task wasn't so difficult. It was frustrating the heck out of you. It wasn't so simple. It was boring you. It was just perfect, right? And there's nothing like it, right? When you feel that sense of flow, whether it's playing music or playing a sport or programming, getting that experience. And there's attributes to this, right? And this is a very, very important part to developer experience, is that feeling of flow and the fulfillment they get from it. And another thing to mention about flow is that it's not just something at the level of the individual developer, but also at the level of the team. You can have flow within a team. And I'll talk about that in a minute. And by the way, this is kind of the sweet spot, although there's a new visualization of this from the author, but I like this old one that looks at, if it's too easy, you're bored. If it's too hard, you're anxious. All right. This is not working anymore. Do something. Did it switch? It did. Okay. It's a bit slow. All right. So let's look at the three of these. Cognitive. What happened here? I don't know. Is there something going on with your computer? You think,
Is it just slow?
Yeah. Does that happen sometimes? Anyway, we'll keep those. Yeah, it's
Sorry, let's see how it goes.
yeah. We switched laptops because I said mine was flaky. And it is. I know. Technology. You just can't trust
That's
it.
right.
Anyway, no. It's probably Zoom, right? All right. So cognitive complexity. Let's look at some research opportunities in terms of cognitive complexity. So one of the things that we need to think about is that we rush to automating things, right? Because it will lower the cognitive complexity for developers, right? In some way. But the complexity goes across the whole life cycle. So one of the things that we need to think about is the net effect on cognitive load or cognitive fatigue. So actually, there's some research that's looking at cognitive fatigue on the part of developers, like how you can get burnout. So all of us have felt that, right? When you can't get access to the information that you need, or you can't get feedback from other people. And so your task is interrupted and you have to switch tasks and you have to keep switching tasks. That's that feeling of cognitive fatigue, right? And cognitive complexity can lead to that cognitive fatigue. Another thing we need to care about is, will automation create technical debt, right? So some of you may remember or had in some of your classes the layman laws of evolution. If software is going to remain useful, it is going to change, right? This is just something that's going to happen. So all of the code that people today are generating using, ChatGPT and Copilot is lovely, but it's tomorrow's technical debt, right? And it's going to have to be changed. It's going to have bugs. It's going to have to be understood. And the other thing is, how does automation impact developer skill, right? And their learning. So I was chatting with some students today, Dai, I think, and Jenny, and they're both looking at learning, right? The impact of automation on learning. And actually, Jessica Kerr talks about this. And this quote came before ChatGPT was a big thing, where she says, the main bottleneck in development today isn't writing code. It's understanding code. It's learning about the code. That is the bottleneck. So she's, a big industry developer and looks at sort of coming trends. And she says, this is what we need to be focusing on, is how we teach people to get better at understanding code that other people wrote, because they're going to have to understand it and change it. So lots of research opportunities there. And then in terms of faster feedback, one of the things to ask is, do these tools that we write, do they provide actionable and timely information? Do they provide it at the time that the developer needs that information? Is the information provided in a way that they can act on it? And to know this, we have to really understand what the developers need. And can automation improve feedback between developers? So there's a lot of focus on feedback from the tools and the technology itself, But what about, and Jim mentioned, I did some work on bots. We were trying to look at how chatbots could improve how people collaborate and talk to each other using chatbots as a mediator that was smart enough to know how people wanted to share information and when they needed to share that information. And as I mentioned earlier, is faster always better, right? Maybe sometimes it overwhelms people. It's too much information. It adds to cognitive fatigue because they have to process it. And then the last one I wanted to talk about was this notion of developer flow, which I'm actually pretty excited about because I have a couple of students working on this. Can this automation lead to boredom and reduce the joy in programming? I know that that's like, a lot of people are like, what? It's just, automating all the boring stuff. Sometimes that can be the fun stuff for a lot of people, right? They actually get a lot of joy out of figuring out which API to use and which calls, in the API to use. And look, I got it. And now you just ask ChatGPT and you have a solution. You're like, oh, that's kind of boring. It was way easier than I thought it was going to be, potentially, right? But another question is, how can we design automation that has baked into it this notion of flow, right, as a theory, and actually helps enhance flow experiences? And how can automation enhance flow across a team? So flow across a team is something that has been observed a lot in some sports. I'll talk about an example of that in a second. And then how can AI be an effective member on a software team? So not just think of it as an automation, but think of it as part of a team that involves other developers and also a community as well. So, yeah. So I mentioned flow as a team. So I like to sail and I still race a little bit. And one of the things that happens when you race on sailboats is that action and awareness start to merge when you're on a boat. You kind of know what other people are going to do on the boat. And you have instrumentation, right, that tells you what's going on, how fast you're going. You have sensors that tell you about the wind and the currents and all these things. And of course, I haven't sailed for the America's Cup, just in my dreams. But, on the America's Cup, they use a lot of AI, they use a lot of data science to feed the team all of this information to help them to make these better strategic decisions. And the way that they design AI, so for the America's Cup, they realize that the team is really, really important. And the team in the America's Cup isn't just the people who end up on the boat, but it's also the people that are developing tools like this because they are essential team members, right? So they really think about that high-performing team as all kind of stakeholders, as part of the team, and they work together and they brainstorm together. Of course, let's see if I can. Oh, my video didn't come through. Maybe it did. Right. How do I go over to the screen? Oh, look at that. I figured it out. This is me using somebody else's laptop. There we go. Got it working. So at the end of the day, though, when the America's Cup team talk about how they use these algorithms and how they use these processes, they recognize that, a human has to decide when to push a button or when to make a move. And if you're asking for why mistakes are made or someone to point the finger at, Jimmy Spithell said, at the end of this race, you're going to see what happens coming up here, although the video is very slow and I'm not sure why. This is a multi-million-dollar boat that's flipping over. And it did cost millions of dollars. Sorry, that didn't work very well here. But the point that Jimmy was saying was no matter how many of these different, signals or AI or fancy stuff that they're using, at the end of the day, a human calls the shots. And it's the same with software development as well, right? A human has to call the shots. Sorry, I've really distracted you. It's a very disturbing image. Software development, unfortunately, is not quite like this. All right, so just to wrap up, how can we evaluate the impact of automation on developers? All right, so no matter how many technologies you implement, and we know this by now, the weakest link will always be the human factor, right? Humans are involved in developing software, right? And so we have to take into consideration that as we're doing our research. I'm sorry, I'm really struggling with this here. Okay, I think it's working again. Nope. All right. I should have kept my own laptop. All right, so in terms of the research methods that we use, so some of the work that I've been doing over the past few years is looking at, as a community of software engineers, what kind of research methods are we using and how often do we actually directly involve humans in our research? And this is looking at automated software engineering, and I did an analysis there, and you can see the red ones are methods that involve people. There are very few, and the same in ICSI as well. There are not so many that involve humans. So, but what can we do? You might be saying, well, you know, studying people is really hard. Anybody agree with that? Right? It's really hard. First of all, you have to find them. Then you need ethics. And then you've got to, you know, collect the data. And then guess what? People don't behave like machines. They get sick. They don't show up, all of these things, right? And then analyzing the data is tricky. But there are other things that we can do. We don't necessarily have to involve developers, right? Although I think we should. But if you can't, maybe along the way, you can think about what you're measuring in different ways. So one way I put it, you know, to think about is not just thinking about what is the impact, say, on the number of bugs in the code, or what is the impact of your new automation on pull requests, to maybe look at some of these other metrics. So for example, if you are designing a code review tool, you could use space with these 5 different dimensions to maybe help you broaden the kind of metrics that you're using in your evaluation, right? So maybe you could look at, you know, code review timing between the collaborators, or maybe you could look at, you know, ask developers to do a thumbs up, right, on the code reviews rather than observing them. And then also in our work, very staggered speech here, sorry about that. We've also taken that developer experience framework that I mentioned earlier, and we've instantiated that in a tool, which together with my collaborators at GetDX, so I should say I'm their collaborator, it's their tool called GetDX. They've designed this tool that allows them to survey a lot of developers pretty quickly on a team and in companies, and to ask them, what are your top pain points? Right. And, you know, what are the areas then after you've done your pain points, it gives them a summary of, you know, what things are working well, what things are not. And then they can use that within the team to focus on what they can do next. So it's a pretty lightweight approach for doing that. And then the next area for looking at research is looking at new ways of probing human experience. So I talked about flow, and some of you might be wondering, but how do you measure flow? Well, there's actually research, a method called experience sampling method for flow. And my PhD student is working on a tool called Flow Insight, which helps developers get in and stay in flow. And her tool actually allows developers to sort of hit a red button and say, I'm stuck, I'm confused on this part of the code. And that signals to people on her team that she needs help. It doesn't interrupt them. When they're ready, they look at that, and then they can jump in and go help her. So bringing that collaboration into the part of the code where they need that help. And then she associates flow metrics with the code so that over time you get a picture of which areas of the code are causing confusion. And if you are going to fix some of your technical debt, you maybe want to think about fixing the parts of the code that cause a lot of confusion. So there's a lot of things that we can do by thinking about the human experience and looking at tools for supporting those. And then one thing I wanted to mention is that these 3 concepts of cognitive complexity and improving velocity and removing friction, these are often in tension. So you might make a change to reduce the complexity, but that may, you know, at the same time, reduce the velocity of feedback. Or you might improve feedback speed, and by doing so, add complexity, right? Increase cognitive reduce fatigue by giving too many warnings at the same time. So anytime you make a change to any tool that you're building, you can think about these 3 aspects. All right. And I'm going to close with the quote that I started with. So by Oscar Wilde, right? So while humanity will be amusing itself, machinery will be doing all the necessary and unpleasant work. And I wanted to close with this because let's not forget what people really like, right? Doing what they find joy in doing. So people find joy in collaborating with people. They find joy in creating, and they find joy in solving puzzles. And so we have to, keep track of that we don't just fully automate away all of the joy out of development and all of the creativity. And with that, I'll just leave with my takeaways. So I talked about, just try to get this to go faster here. Study developers for inspiration. Consider how your solutions can empower the developer experience, and use research methods that, even if they don't necessarily directly study developers, that they at least take into consideration behavioral aspects of developers. And yeah, with that, I'm happy to end. We have a few minutes, right, for questions, right? Yeah. Sorry for all the breaks in there. Questions, thoughts? Yes.
So this kind of harks back to our earlier discussion about Teslas. But Teslas are very advanced, and autopilot is very, very good almost all the time. But that gives humans the task of being vigilant for extremely rare events, right? Yeah. Misbehavior of the autopilot. So I'm kind of wondering about the use of Copilot and ChatGPT, things like that, to write code. It's going to be really, really good at writing plausible code. And it's really good in general, I guess, and we'll get better at writing code. It seems like it's going to create a few extraordinarily difficult bugs to find because everything is so plausible. It's based so much on what it's seen. So just kind of wondering, doesn't that kind of change? I don't know what that does to the user experience, but it makes it more difficult to be aware of the bugs that come up, and it's a really difficult task to be vigilant to that.
Yeah, I think that's a really, really great point. And I think it's a big concern. And I think it's even a little bit worse with ChatGPT and Copilot. I mean, at least in the car, if you run a red light, for example, or you hit a curb, right, or something, you kind of know, right? Like the mental model of driving is fairly simple, right, compared to what we have to learn when we're writing code. And one of the things that I worry about is that developers are going to be learning, right, from looking at this auto-generated code, right? And they're going to be learning stuff that's wrong or insecure and not even know it until something breaks, right? It may not actually show as a bug until later on down the road, right? So yeah, I think there's lots of exciting work though, on the other hand, to look at that. On the flip side, I can argue. I was telling Jim earlier, I have students on both sides of this camp in my lab at the moment. And so we have very fun arguments, about the benefits of using tools like ChatGPT and Copilot and the risks, right? And I think we need to, as researchers, engage in that debate and think about both sides. So some of the benefits. So one of my students was saying, one of the other students was onboarding him to a framework, and Brennan was the person who was onboarding Derek. I'll just use their names. I hope that's okay. And Brennan said what he did was he explained what he wanted the code to do in natural language. And then Derek would write it into the tool, and then it would generate the code. And Derek said he could not have learned that code faster. He couldn't imagine any other way to learn that code. So there's, benefits in learning. But then when things go wrong, and humans are very, very bad monitors, we're very bad at observing small things, right? And we, build mental models where we see what we want to see. There's some big challenges ahead. Yeah, some very big challenges. Yeah.
Yes.
I thought there was a hand on behind, but yeah, go ahead.
Yeah, so a couple of years ago, there was a book written called Normal Accidents.
Yes.
The thesis of that book is that a lot of the very serious accidents are because people cannot form mental model or an idea of how the whole thing
Yeah.
works.
Yeah,
You know, are we facing
could be.
the
Yeah.
same thing here? I mean, you know, you see a few instances of how something works, and you may be inferring this model and think that you know how it works. But with software, especially, you have very discrete points, you know, an if or a case statement can
Yeah.
result in totally different behaviors.
Yeah, no, totally. Actually, I haven't read that book in about 20 years. I'm going to look at that book again. Thanks for that reminder. Yeah, no, I think definitely that's a challenge. And, you know, it reminds me of actually Mary and I were chatting as well this morning, and Mary was saying, you know, AI isn't changing software engineering. You know, we still have the same problems. The problems that we're talking about are still the same problems, right? That there, you know, can be a bug somewhere that people don't spot and their mental model is wrong. But I do worry a little bit, you know, that the automation can amplify, right, these problems somehow, you know, and that is something that we need to pay attention to. But yeah, thanks for the reminder of that book. Was it Vincent? I can't remember the author.
Perro,
Yeah, Vincent Perro wrote the book. It's a very interesting book.
Charles or Vincent?
I think, yeah,
Perro is
I
the
think it's Vincent, but maybe I'm wrong. Yeah, Andy?
So you have the slide that I was like, I totally love you talking to this one slide where you said humans are the weakest link. in the
Yes.
system. I'm like, they're the weakest link, they're the strongest link, they're the only link. World trust.
Yeah. Okay, I'll update that slide.
is the
Yeah,
Goal.
yeah,
And when
Yeah.
mental models of what we think we want to build don't match up with reality is where we find these bugs. It's not only in
yeah,
the automation that doesn't produce what we can imagine, but also the failure of our imagination to think of all the possible choices
yeah.
it's all in us. Like the machine is, it's great, it's really nice to help us do all these things, but it's really almost besides the point. We're the ones with both the problem and the solution and everything. The machine's just a tool here. The automation is just a tool.
Yeah. So, yeah, thanks for that. I'll update that if I give this talk again. But yeah, I mean, Jean Yang said, you know, people are part of the code. I think what you're saying is people are the software in a way, right? Like they're in caps, right? It's about the people and what's in their brains, right? The Peter Nauer thing, right? It's about our theories, right? About what is possible, how things work, and what we could do, right? Yeah, really good point. Thanks, Andy. Yeah, very.
I'd like to try to tie together the questions of cognitive load and automation and the ancient lines of code measure of productivity. And I'd like to do it through abstraction.
Yeah.
So cognitive load is exacerbated when you have to deal with multiple levels of abstraction at the same time. The code and the makefile and the UML.
Yeah.
And so it's somehow Ackermann in the number of lines of code cross the number of different languages you have to think it. So I think there's a measure, an indicator of cognitive load that's related to the number of different frames in which you have to think at once.
Yeah.
With respect to automation, what I learned about automation is that when you automate, you tend to automate the explicit functions of the previous system, but you tend to miss out on the implicit functions. And you talked about side effects. And I think a lot of times it's the other way around, that the things that you see as side effects are actually failures of automation to completely automate all of the things that were going on in the system before you started to automate it. And so the act of automation, to get complete automation, you need to dig out those implicit bits as well.
Yeah.
Okay, now I want to bring in abstraction. For me, a measure of progress in software development and programming languages, and you can kind of draw this on a graph through time, is how big is the granularity? What is the size, the conceptual size of the chunk that you use without thinking inside it? So in the 1950s and 1960s, it was the individual machine instruction. And we moved up to subroutines, and then we moved up to objects, and now we have frameworks. some of these are now so well automated that we really don't have to think inside them. And so the conceptual load of understanding what's going on down inside doesn't bottom out at the machine language anymore. It bottoms out at whatever that fully automated level is.
Until it doesn't work.
Until it doesn't work, but for the
Yeah.
most part.
Let's just say,
for the
assume it
most part,
does.
when-
Yeah.
when doing development, you
Yeah.
don't have to think all the way down. You only have to think down to where the automation is complete.
Yeah.
And so there's kind of an expanding event horizon.
Yeah.
Or an expanding automation horizon, in which there's not a sharp line, but there's an inner core of fully automated things and a horizon of partially automated things. And the width of that band of partially automated things is where the cognitive load is coming from.
Yeah.
And we keep pushing that out. We always have greater aspirations.
Yeah.
But I want to ask you to talk about how you control the width of that band of partial automation in a way that helps the developers think. And then the final link to the lines of code measure is lines of code has always frustrated me because it's a measure of input.
Yes.
It's a measure of how fast can you type,
Yeah.
not how much are you producing.
Yeah.
And that ties to the granularity of the abstractions, because the bigger the thing you can create with a line of code,
Yep.
the bigger the chunk you can create.
Yeah.
Anyway, the question coming out of that is how do you think about, how do you study, how do you manage the breadth of the automation horizon in such a way that it keeps people happy and productive?
Wow. Well, this was recorded because I want to go back and listen to all the things that you said, because you said a lot of really interesting things. You're absolutely correct about the abstraction and about cognitive load or even cognitive fatigue. So when we do things automatically, when we don't have to think about them, we don't have cognitive fatigue. Right. So, so if we're working at that level of abstraction and we understand it and we trust it's doing the things that we do and we're familiar with it, we don't have a lot of cognitive fatigue. The problem sometimes comes in, I'm sorry, I'm going to get to your question, but I just want to share a couple of points. Some of the problems comes in when you're dealing with a level of abstraction that you don't fully understand. Right, because now you got to go below, right, and try to understand what's below. But there's also complexity that goes across. So there's dependencies. Right. So the part that you're using depends on all of these other things, which is not necessarily, which can be hidden by abstractions, but it's not necessarily hidden by abstractions. So there's a lot of cognitive fatigue there. I just wanted to mention that. So this width thing of the semi-automated thing, this is such a good point. And it's been studied actually a lot, in the CSCW literature, right? You'll remember the phrase automating a fiction. Remember that? I think that was Liam Bannon that said that. And that's what happens sometimes, right, with the automation work that we do, that we pick some part of it that is kind of, I shouldn't say it's easy, but it's easy to put a box around it. It's easy to define it, and we automate that part. It's the clean part, right? And then we forget about all of the other parts around it, that width that you're talking about. And that's where people come in often, right? The way that people work, the way that they forget stuff, that they make mistakes, that there are 3 people that need to be accessed and one of them is in a different time zone. So I think studying people more and thinking more in theories of not just how the mind works, but theories of how groups of people work in combination with the automation is going to help us stretch that a little bit. Thanks for the question. Did I miss anything else that you said that I should address?
That's a really good first cut at an answer.
Okay, thank you. I think that was a compliment.
Yeah, so it's kind of connected to this, I guess. So all of the things that you mentioned in the talk, I guess it's almost inevitable for us to do actual studies with human, to understand the human aspects of it. For example, flow or cognitive fatigue and everything. And then another thing I've recently noticed is that the cycle of new automated tools coming out is getting faster and faster. So like yesterday I saw Copilot, and then today there's ChatGPT, and then tomorrow I don't know what that will be. But we somehow need to study them, and then the goal of the studies will be to make the next automated tool to consider these human aspects or
Yeah.
side effects that we find out from the studies, so that to make better tools. So I don't know, it's really hard to know when is the right time to actually go deep and study.
Okay, this is
Beautiful.
such a good point. It's such a good point because people change as well, right? The way that we interact with these tools. So if you watch students using Copilot or ChatGPT, they change how they start querying, right? You probably found it yourself. They start to change how they think. And how people use technology changes and rewires our brains, right? So Nicholas Carr showed that as well, like how the internet and social media rewires our brains, right? And so what this is going to look like with AI, you're right. Like if we study the developers today and how they're using, suppose I have a new version of, a bot, right, that uses ChatGPT. The way that developers 6 months from now use it could be completely different, right? So do you study now? Do you study? I don't know. I
Wish you had the answer.
I'm sorry, I don't. I mean, I think one answer is don't ignore people, and maybe we need ethnographic, or sort of longitudinal ethnographic style studies, I think, to really understand what's going on. We need to be embedded, right? So that's why, I have some students in my group are saying, don't touch that ChatGPT thing. And I'm like, no, we have to. We have to understand it. We have to use it. We have to be part of the system to be able to observe. When I did, Jim mentioned the work I did on social media. When I first started studying social media, I wasn't using social media. I'm still a bit of a Luddite, to be honest, But, I wasn't using it. And I was trying to analyze data that I didn't understand. I was trying to analyze, I wasn't recognizing patterns of usage because they weren't familiar to me, right? So it's the same with, AI. I think in research, we're not in a company, so we're not being driven so much to, okay, maybe we have to make money somewhere, but, we're not being driven the same way. We can take the time to take a broader, more holistic look. It is a system. It's an entire system of how this is going to be used. And anyway. So I'm sorry I don't have the answer, except we're going to be all very, very busy. But not writing papers. Let's not write so many papers. Let's study things more. Yes, Michael.
So thank you for the fantastic talk. I want to gently push back a tiny bit. So
That's what we're here for.
I had a really fun experience one time. I got to ride in an elevator with Don Norman and talk about buttons.
Yes.
So you had this analogy with America's Cup, and they said ultimately it's always the person's fault.
Yeah.
Right. And I feel like that kind of goes against a little bit maybe what Don Norman might say, right? Where if you design the interface in a way that encourages people to make mistakes, then in some ways it's the interface designer's fault, not the human who made the mistake, right?
Yeah, fair.
So where is the tension?
Fair.
I think there's a tension there. Do you have any thoughts on that tension?
No, it's fair. That's a really, really good point. And I think what you're saying is we have a responsibility, right? When in the feedback that we have in developing these tools to recognize, right, that we can be designing tools that can do harm, right? If taken with complacency. You're absolutely right. I'll fix that slide as well if I give this talk again. But yeah, no, that's a really, really, really good point. That part of responsibility for being aware of that, risks, and then what can we do to avert that? Yeah, great point. Thanks, Michael. Yeah.
So moving towards what Dai was saying. What do you think that will be the next trend after ChatGPT?
I'm all out of what's next now, because it's mind blowing. I find it mind blowing what's happening right now. I think it's, I think after the internet, and then I was, working on software engineering for a long time. I think, not that long ago, I've said to people, things really haven't changed that much in the last 10 or 15 years. Okay, Stack Overflow was a change, right? Social media was a change. And then after that, okay, there was DevOps, which is important. But there wasn't like a huge thing. And now we have this huge thing, and how it's going to evolve and how people are going to use it and how it's going to shape. I don't know. I mean, what is the next big thing? People, maybe, understanding people more, more kind of thinking about the effect that these technologies will have on people, and issues of trust, issues of ethics. There's also, I was mentioning, I think to somebody this morning. There's a movement in the technical community. It's called the Fediverse. Anybody heard of the Fediverse? So it's kind of like this, yeah. So you probably know more about it than I do.
It's Mastodon, right?
Yeah, so they're developing Mastodon, and it's almost like this rejection, right, of like the AI stuff to a certain extent, and big tech kind of controlling everything. And it's like taking into their own hands as a community, technology and going back more to using tools like email, so that when you get some information, or you can trace who is the person behind that information that you're being given. Because there's a concern, right, with disinformation, right, coming through these tools that look like the real thing, right? And we've lived through the whole pandemic with disinformation and so on, right? Depending on which side you believe, there's disinformation on both sides, I guess. But anyway, I don't want to get political. But there's a lot there. I think maybe understanding those trends as well, looking at the people who are rejecting it and understanding why, and looking at what they're doing, and then maybe looking at what they're doing and what the AI stuff is doing, and maybe meeting somewhere in the middle. Maybe that's the next trend, a meeting of focus on people and AI. Yeah.
Yep. But on exactly that point, reverting to email because you have provenance, who sent it, when they sent it. That's an important conceptual notion. But that's not the only way to achieve that. We can take another step forward from where we are in social media. We have lots of data now. Data is pretty cheap. We could imagine attaching more provenance to social media and more credibility and more authenticity, so that we could achieve the ends of going back to email without abandoning whatever benefits there are of the other media.
Yeah, I mean, that's a really good point. There's some concerns that is open to attack. But
of course,
but there is with email as well. There is with people pretending to be people and so on. I think that's a really good point, that could be done. And I think this, the Fediverse is trying to stay away from big tech, because they're trying to be less focused on capitalist, kind of motivation and more about, supporting humans, right? And humans helping other humans and so on. So there's some interesting stuff, I think, going on there. But yeah, that's a really good point. Yeah, I know I don't want to go back to email. I can tell you. Yeah.
Maybe one more question.
I'll try to get this short. So going back to the earlier question about full on. I really like your point. I really like your talk overall, because your point in general is, let's not conflate, let's not simplify the definition of software engineering to something technical, because in the end it's a socio-technical system that involves people. And the reason for that, I see it as being a twofold loop, right? Part one, we're of the biological creatures on this planet, we have the greatest cognitive capability combined with opposable thumbs. So that's the thing. And so because of that, we've been able to, part two, form this economy in which humans are the primary agents. And so our wants and desires define what's important in the economy, right?
Yeah.
So software engineering fits very firmly into this economic model where what matters, and especially we see this in the information economy, is social media, why does it exist? Because we like talking to other humans. It doesn't matter what matters is what humans want, right?
Yeah.
But I guess the reason that I raised my hand earlier is because I see a potential for a break in this loop, in which we are no longer the most cognitively advanced beings that exist on this planet. And so then our wants and desires no longer define the economy, because we no longer have each individual human no longer has, is able to compete, I guess. So what are your thoughts on that?
Scary. I've thought, I wouldn't be able to articulate it as well as you just did, by the way, but I've thought of some of these things, some of these challenges. I was thinking about it as I was sort of, tweaking my slides a little bit. And I was, one point that I made was thinking about was, do people have, so it's about creativity, people are, the most advanced cognitively, but, I think there's a concern, and I share the concern that maybe we won't always be, right? That machines will be more advanced, and they will be driving at, these economical or capitalist, whatever kind of drivers, right? Towards doing not necessarily what individuals or even groups of people want, right? So I do think that is a concern. And I was also thinking about you know, originality, like what's original thought? Like, have I ever had an original thought? I'm not sure I have, because everything I think or, you know, is from something I've read or somebody I've talked to or something I've learned, or, you know, it's, you know, I build on things that I've been exposed to before. So, you know, yeah, I mean, you can look back on history and, you know, I was reading this book called, Tools for Thought, I think it's called, or Thought for Thought. What did I say the name of it was? I can't remember now anyway, but by Howard Rheingold. And there are definitely, when you're reading his, you're like, oh yeah, okay, that person was a genius, right? They had this leap that nobody else would have had. Like with machines, if we go all the way back, imagine we had machines and we went all the way back to the beginning of the computer. I know that's sort of like hard to imagine because we kind of need them then, but you know, would they have imagined what Babbage did, or Lovelace, or Boole, or Turing, right? Like those were like, right? You know, are machines capable of those kind of original thoughts? I don't know, right? Anyway, I know that's not quite the question you asked, but it's a little bit about sort of, you know, what is the, you know, can machines surpass us, right? In terms of creativity is something.
Yeah, I mean, ChatGPT definitely seems to debunk a lot of people's preconceived notions about what creativity is and what is possible for a computer to do or not.
Yeah, yeah, it's changed what we think, right? For sure.
Okay.
You could be right though, but.
Let's have to speak.
Yes.